Hello and welcome to this Omega Friday session.
Yes, today we're going to have a deep dive into the BIM, BIM behind the scenes. So we are joined by Paul Wiik.
Yes.
He's the product manager of BIM in Omega 365.
Yes, and looking forward to get something behind the scenes, get some technical, and we'll see here we have Paul with us joining.
Hello.
Live from Kristiansund.
Hello.
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 You can see your screen with our headquarters in a 3D model, where actually we are here today.
Yeah.
Yes. Shall I just jump right into it?
Yes, you can do that.
Okay. So in order to get this BIM viewer working, there's a lot of stuff going on behind the scenes. Typically, a building model like this, or it could be any infrastructure type of project, as well as buildings. It consists of multiple files containing the geometry and also the data. Like if I select an object here, you get a lot of object information about that object. The geometry and that information are stored in IFC files, and one model can consist of multiple, usually does. Like one here is mainly for architecture, but you could have several architecture files. Like some bigger projects have multiple buildings, so you could have one architecture for each building, and you have interior architecture and electrical and VVS and stuff like that in separate files. In order to be able to view them like this, because that format isn't practical for loading directly out into the browser, we need to do processing in the back end. So here's the diagram I made. The blue boxes over on the right side, it's sort of standard app frame component, and the white ones are related to BIM. So there's mainly there's this storage account, and the goal is to put geometry into this blob store, and also to put object information into the database. But since the files can be really big, like 1 gigabyte per file, it's not something that we can process directly in the web application or something like that, because it would be too resource demanding. So on the left-hand side here, there's a shared batch environment. That's a group of resources that can be shared by multiple customers. So you can have several of the green ones here using one of the yellow ones to process files. So if I go back to the browser and we look at the BIM setup screen, let's say I have a new batch of files here and I want to process them to make the geometry and object data available. I multi-select the files like this and I say start parsing. What happens then is it creates a new job, and it's sort of adding these different parts of the process to that job, and we can see the progress for each file here. You can see some of the files they have different percentages, and that's because the total amount of tasks for each file can be different based on the differences in how the files are set up. So like this one, it's mainly just to extract the data, import the objects, and generate the geometry for the full model. And this queue is just an indicator that it's put on a queue. So if I go back to the diagram and switch on this, So this is what I did in this BIM setup screen. I said start parsing. It sends an API call to the web application. This collects a bunch of data and creates a job in the DB. That's just mainly to log and follow the status. Then it posts a message to this queue that it needs to process this job. This queue is in this customer box, but there's a trigger in this function app that sort of just passes on that message over to this queue. Again, it's triggered in this function app, and this Azure batch is what's actually loading the IFC files and splitting them into geometry and object data. So it creates a job here, and like I now selected multiple files, so it will create then inside of that job in Azure Batch, it will create tasks for each of the files, and then the batch account needs to create some nodes in a batch pool. So this will take some time before it starts processing. But the advantage is if I selected like 200 files, it would create more nodes in that batch pool.
And this is then the part where our architecture is serverless, and due to the need of scalability. If you have one file, 10,000 files, multiple customers.
Yeah.
Yep.
So there's information sent along with this queue message, how to retrieve the IFC files, and that's from the standard AppFrame file store. So it doesn't copy the IFC file or send it again. These jobs in the batch go directly to the file store and fetch the IFC file and read it. So then the next stage, I can switch off the start to make it more clear. So these apps then write the geometry to this blob store, and the object data that's supposed to go into the database, it's written as JSON files also on the blob store, because we don't want this to contact the SQL Server directly, and also because of timings and the amount of data. So some of this information for the biggest files we have for customers now, there's I think 8 million properties in one file. I can show you what I mean by properties if we go here. So for this piece of the wall, each of these lines in this table on the left-hand side here is one property, and the biggest files, one single file for a customer, has 8 million of those. So it's big data amounts.
Yeah, enormous.
Yeah, and those are stored then as JSON files there, and during this there's API communication between the apps and the AppFrame web. That's just to update status and other small communication.
So you get the progress of the job, etc.
Yeah.
Yep.
If we go back here now, it's still waiting for this batch job to start. It can take up to 5 minutes, I think. So next part of the flow is this application is done eventually, and then this batch orchestrator realizes that okay, we're done with one file now, sends a message back to this storage queue. Again, it's triggered in this function app that tells this AppFrame web that there's a set of JSON files with object data that you need to import now. And then this is something new that we did quite recently. Instead of this web application reading the JSON and feeding it into the database with a bulk insert. And now this web application just starts stored procedure, and that stored procedure inside SQL fetches the JSON and merges it into the database. It's a big advantage because then we don't have to drag all that data through the web application. And also, if you do a bulk insert and there is already data there, you basically have to delete and then reinsert everything. And that's a lot of write and delete on the database, which it doesn't like.
Yeah.
But when you read the JSON directly in SQL, you can do a sort of a graceful merge where you update what needs to be updated, insert what needs to be inserted, and delete what needs to be deleted. So if the files are the same and you just rerun the import, you will basically not update, insert, or delete anything. It will just check that everything is up to date. So once that is done, we have the BIM viewer that we started with, and that one reads geometry, sort of serverless, like Jan Christian said, because all the geometry is stored in a way in this blob, where it doesn't need logic on the back end in order to send geometry to the viewer. So the viewer itself knows how the geometry is separated, and it just fetches what it needs directly. And if you click an object, then it retrieves the object data.
Yeah. Cool.
So yeah, it's quite nice, and it looks, and it is actually a bit complicated, but the thing is it's very scalable, and also it's quite tolerant to faults, because like when you use these storage queues instead of contacting the service directly, you get retries and stuff like that. And if a service is, let's say, the web is down for a period of time because someone stopped it, then okay, the message is still in the queue and it will keep retrying. So it's better in that way. And so what I describe now is the sort of base scenario where it's the initial one where it extracts the data. But since we already have this infrastructure in place, we now also use the same structure to do other smaller tasks that we would sort of normally do in the web application. But we have this sort of flow already present. We can push other sort of computational tasks through the same logic and get them processed.
This was great. Thank you, Paul.
Yeah, and the result we can surely see when navigating around in the 3D viewer. The performance is great, and
Absolutely.
It certainly scales. And we see now more and more of our clients are interested in our BIM features.
Yeah.
So yeah,
and it's continuously being improved. Both the back end, of course, the front end, the viewer. And there's also a native mobile app which being developed and is in the pipe as well. We'll can have a look at that one in another session.
Yeah, because in that meeting room that you just scrolled into, I have to go now to attend another meeting.
Yeah. Perfect. Okay.
Yes.
Thank you, Paul. And this was for this session. We'll be back another Friday.
Yes.
Yes.
Next Friday,
Okay.
actually.
Yeah.
Yeah.
Yeah. Bye.
Okay.
Bye-bye.
Bye-bye.